So hi, my name's Ryan. If you're paying attention to your program, you might have noticed that the title of my talk has changed. It used to be Testing for Graceful Failure with Vaurien and Marteau, and I gave a version of this talk at PyCon Australia a few months ago now, I think. At the time, I had to put a little disclaimer in at the end of the talk saying, well, this is the tool we're using now, but we're kind of working on something better. As of about 2 days ago, the shiny new thing is ready for public consumption, so you guys get to hear about the cool new thing. Not Marteau, loads. But the gist of my talk is very much the same. And good news for the final talk of the conference is one more talk about testing. Which is fine, because the funny thing about testing is no matter how good you are at it and how much of it you do, it's never going to be quite enough. All right, you can have a huge suite of unit tests, 100% statement and branch coverage, you can have an epic suite of integration tests, and you put a software product out there in the real world where it has to interact with users, where it has to depend on other software products and other systems for its correct functioning, stuff's going to go wrong. I'm actually going to start from the assumption that you're in a pretty happy place. You know, you've been paying attention to all of the other testing talks that you've seen lately, and you have I do web applications, so we'll start from there. You have an application, you know, it's tested and you're confident that it works. You know how to deploy this and you know what this thing's going to look like when it goes live. And you know how to detect if there are things going wrong in your application. Now this is a really happy place for an application to be like. I've written a lot of stuff that never got to this point. But we're putting it out there in the world, and we want to know what is going to happen now when things around our application start to break down. So I'm not so much interested in, well, how do we test that our application is doing things right? I'm interested in how do we test what happens when things start to go wrong. I'm coming at this from a position on the Mozilla Services team. So we're a group within Mozilla that run a lot of backend services in support of Firefox, in support of the new Firefox phones and stuff like that. So we run the servers behind Firefox Sync. We run the marketplace app, which you're going to go to and buy all of your apps from when everybody gets their Firefox OS phones, eventually in Australia and New Zealand. We're running a push notification service for the phones to get, you know, email notifications and stuff, and a bunch of stuff in the pipe. So what I want to show you is some of our kind of organic processes and tooling and things that we've learned to not make these services fall over. As is the usual case, it's very much a case of we failed to do something and then things went bad, and then we try to figure out ways to avoid that happening again. It's very much going to be just a bit of a demonstration, like not a tutorial. If you think this stuff sounds cool, come and chat with me afterwards, hit up the docs. This just give you a bit of a flavor of some of the stuff we do. So I'll tell you about a real life bug that kind of happened on my watch. And this is a somewhat simplified diagram of the servers behind Firefox Sync. All right, it's a skinny little Python web app running inside Unicorn, takes JSON data in from your browser, shoves it into MySQL. Because the Firefox user base is, you know, fairly sizable, the app does some application level sharding. So every user who comes into this web API is assigned to a particular database host. The web app figures out where you're supposed to be and it directs your data to the right place. What happens if one of these databases goes down? Right, it starts thrashing to disk and queries get backed up, or there's some sort of network problem between your web app and your database. According to the diagram, what should happen is users destined for this unhealthy database, you know, they're kind of screwed. Their database is down, you know, we can return them an error, there's not much more we can do. Users whose data lives on all of these other databases should be fine, right? There's no problem there, we should be able to continue providing them with service. Real life is, of course, never as simple as the diagrams would have you believe, because inside this little Unicorn web server process is a bunch of worker threads. It turns out when this happened in real life, sort of every time a user comes in for the sick database, one of these worker threads goes to talk to the sick database and it doesn't come back to the pool. So if you have enough load going on all at once, you know, you have enough queries that are getting stuck down this path, eventually your whole web server comes crashing down, which, you know, is bad news. That is not a graceful failure. That is a cascading failure of an epic sort. And if anybody actually uses Firefox Sync here, you may have noticed we've had a few of these events from time to time. Every time one happens, we learn a little bit more about how not to do it in the future. But I mean, the tricky part is, how do you find bugs like this? Like that is a tricky interaction of a couple of different components that are not even necessarily in your stack, in your code. It's part of your deployment environment. So it's probably quite unlikely that you're going to have a unit test that uncovers this behavior during development. You could try and mock out your database and simulate various kinds of failures and error conditions if you know what you're looking for. In our experience, sometimes the only way to find these bugs is to do it live, right? To actually deploy your application into a state that looks similar to how it will be in production, to put it under the kinds of loads that you expect it to see in production, and then break stuff around it and see what happens. Where you go from that is up to you, but this is how we find these things. So step one, deploy it. And this is very much going to be dependent on your setup, like you may be deploying into AWS or Heroku or something like that. I'll just give you a little demo of just to set the flavor a little bit. So I've actually had this running on localhost, but we'll pretend I have a special version of the Firefox Sync server set up just for this demo. I'm going to talk to it using requests. I'm going to put in my username and password, so just forget you saw that. So go nzpycon.services.mozilla.com, and I can poke at this as a simple, RESTful JSON API. So I can say, all right, what collections do I have synced? I've got some prefs, I've got some tabs, I've got some bookmarks. What information do I have in my bookmarks collection? Thank you, it's fake. I have a basic set of bookmarks and so forth. So that's our starting point. The next thing we're going to do is stress it out. And the tool that we built for doing that is called loads. And this is new and shiny and very exciting. The idea behind loads is to let you take kind of what I just did, what you would do with best of breed Python tools for interacting with a web service, and then just run it at massive scale, in kind of a real-time distributed fashion to generate lots and lots and lots of load against your service, and then pull the results of that out and analyze them in various interesting ways. So it's kind of still a little bit green, a little bit new, but hopefully what I'll show you today kind of might spark your interest a little bit. So I'm going to start a little unit, like a test-like file. I'm going to import the loads module. I'm going to hard code the URL because you can send this in at runtime via some command line flags, but this just simplifies things. I'm going to write what looks very much like, is a standard Python unit test inheriting from this special test case class. So one of the nice things about loads is that it has baked in support for the request library, which everybody should be using to talk to HTTP stuff. You get this special request session object on your test case that is instrumented with a bunch of logic to measure the requests and see how they're going. So this should look pretty much exactly like what I did before, except I'm just turning it into a test case. And I've recorded all of my typos for posterity. So get my collections. I'll check that yes, the bookmarks are correctly being reported from the server. I'll go ahead and load the bookmarks and check that they came back correctly and that sort of thing. You can imagine me fleshing this out into a much more thorough description of what the service is supposed to be doing. Given that, I have this tool called loads runner. I pass it the path to that particular test case in much the same way as you might pass it to nose or something like that. Bam. It's run that precisely once. So you can see I've got a total of 2 hits, one for the collection, one for the bookmarks collection. And it's giving me some basic statistics about my server. It's kind of ruining the illusion that this isn't running on localhost because it's reporting the actual IPs that it talks to. So from that starting point, all right, good, this test case is working. I can now just start asking loads to do more and more stuff. So all right, I'll put in, all right, instead of just doing 1 iteration of that, I'll do 5 because I don't want to stand here all day. So the number of hits has increased. Alternately, I could say, run that test for some duration. 5 seconds is a good start for a demo. In sort of services, we would run like a 24-hour load test before trying to push anything out to production. So I've got a bunch more hits against my server. I've got some probably slightly more realistic statistics and so forth. you can, crank up these numbers and get basically as much load as you can out of, one little laptop, in my case, sitting on the other side of the Pacific to the servers that I'm actually interested in testing. When that becomes not enough, you can then ask loads to send your test cases off to what we call a broker, which is just another instance of loads running somewhere maybe closer to your server, a little bit better located or on a bit better hardware. And it does that by just, oh no, I'm not up to that part yet. You can ask it to run multiple users concurrently. You can talk to a broker via a 0MQ socket. So I have one running on localhost here. And basically hand off the work of running your load tests to a dedicated cluster. Good. And if that one machine is still not enough, you can then ask the broker to acquire multiple machines and run these tests in parallel. So I can say, all right, give me 2 agents, and I get correspondingly more hits going on. I can ask for 3 agents. I get correspondingly more hits going on. I can ask for 4 agents, and it fails because I only started 3. But you could make that cluster as big as you like, as big as you need to try and make your service fail. That, I think, yep, good, that's the end of that. So the idea is that you can sort of start from the things you know, start from these kind of best-of-breed tools for interacting with web services. Build something that's kind of neat and small and you can run on your own machine. And just by using the stuff that Loads gives you, kind of go from, oh, I'll just run a quick test on my local machine, to I'll distribute this to a dedicated machine, to I'll distribute this to a whole cluster of machines that I've got running. That will eventually cause my server under test to fail, or at least to approximate the kind of loads you're going to see in production. So all of the arrows in this diagram are 0MQ kind of like a custom protocol for each of these pieces to talk to each other. So one of the interesting things you can do, I have the somewhat dubious fortune of being assigned to a Node.js project at the moment, which is fun in a lot of ways and not so fun in a lot of other ways. So, all right, we want to test a Node.js project. We take out all of these Python agents and we throw in JavaScript agents that are running versions of our JavaScript code that know how to talk to this particular application, but know how to speak the same protocol and can talk back to the broker and back to the runner to report back the progress of your load test. So it's kind of designed to give you a lot of flexibility for ramping up these tests and plugging in different pieces that you need. How are we going? This is kind of in progress, but we have a little bit of a kind of web interface. So if you've got, all right, I want to do a bunch of load testing, I'm going to spin up a cluster of machines in AWS or something. It has a little bit of a web interface that can tell you what it's doing. So I can say, all right, nothing's running, obviously, because this is a snapshot. But I'll have a little history of the tests that it ran. This is one that failed. So it ran for 6 minutes. There are a bunch of errors, obviously, because the server wasn't actually running when we tried to do this test. This is one that went okay. Had 1,000 successes and stuff like that. Yeah.
Is this built on unit tests? So I have the normal unit test assertions.
Yes. So that loads test case object is a subclass of unit test case. Correct. The other thing we're kind of still working on is various visualizations for this stuff. So you saw that the console runner kind of gives you a little summary of the characteristics of your requests. One of the things that we've got mostly working now is you can export all of the requests that happened in this load test session into a format for a tool called funcload, which is actually what we were using before we started building loads. One of the things it does really well is generate reports. So you can spit out all of the requests and how long they took and what their status codes were and so forth, and have it generate little graphs for you and stuff like this. As we go forward, we kind of want to do maybe like some real-time graphs and fun things like that. But this is not a bad start. So yeah, real-time graphs, runners in other languages. This is kind of, this project is just kind of getting up to speed, getting a bit of momentum. If you're interested in some of this stuff, I invite you to insert your needs here. As one of the joys of working for Mozilla is that we're free to kind of take other people's needs into consideration in these tools. And people from the community want to collaborate on this stuff. Like, that's awesome. That's something that we're really keen to do. So, yeah. Okay. We have an app standing up in something that looks like production. We have an app suffering under the kinds of loads that it might see in production. The final interesting thing to do is break it. And personally, I usually get this step for free. Maybe you guys, you have to try a little bit harder to make that happen. One of the fun things we kind of did by accident with the Firefox Sync server is just, all right, in the middle of a load test, just restart your database and see what happens. You might think, all right, restart your database. What should happen is you get a bunch of errors because the database has gone down. And then when the database comes back up, all the errors go away because your app should reconnect to the database and so on and so forth. What actually happened when we tried that was the errors, we got a bunch of errors, and then the errors got less, but they didn't go back to 0. And we tracked it all the way down to a bug in SQL Alchemy in its connection pooling logic that only kind of showed up under really heavy load in this very specific series of exceptions and exception handling that would leak connections from the pool. So that's a fun experiment to try. If you want to get a little more deliberate about it, we have this thing called Vaurien. Vaurien is a misbehaving TCP proxy that you basically can insert in between your application and the various other services that it relies on. And it will act as a proxy, but kind of a really bad one. So it knows how to speak some application protocols like HTTP, Memcache protocol. It knows how to give you various kinds of errors that you might see in production. It also knows how to just, terminate your connection in the middle of a transaction, or take your connection and then hang on to it and not do anything with it. And all sorts of fun things that can happen in real life, but don't necessarily make it into your tests. So this is what it looks like. I'm going to do essentially that dance with requests again, but instead of talking directly to our web server, I'm going to talk to Vaurien as a proxy. So we'll start it up in another thread here. It's going to listen on port 8000. It's going to talk to the web server. It's going to talk to a web server, and it's going to speak HTTP. So by default, nothing happens. I haven't told it to do anything in particular, so it's just going to act as a transparent proxy. So this will look exactly the same as before, right? Same. What I can do with Vaurien is switch on various kinds of error behavior. So for example, I might say for 50% of requests, insert a delay. Right? And it will obligingly delay. Not all of my requests, like some of them will get through, but approximately 50% of them will have this delay. I can ask it to insert an error. And because it knows it's speaking HTTP, it will give us HTTP level error codes of the sort of thing you might get from a failing web service. Not all the time. Sometimes. There we go. One of my favorite ones, I can just say, all requests that come in, hang them. Just we're having some problem with the switch, your connections aren't going anywhere. And this is a really good way of testing two things in your application. The first is whether you can actually interrupt something that is hung. And you'd be astonished the number of things that won't correctly recover from a hung socket, even by pressing Control-C or something like that. The other thing that's really good for is checking whether all your timeouts are working correctly. And one of the many nice features of requests, it has excellent support for timeouts. And this is one of the things that can be really hard to do in a mock situation. Like, it's really hard to pretend to be a stuck socket and get your program to behave in the same way it would in real life. So that's fun, but it's kind of a very blunt instrument. So one of the things I prefer to do with Vaurien, sort of once you've played around with that a little bit, it has this little control socket that it can listen to over HTTP. So it's now saying, right, I've started a secondary HTTP server on port 8080. By default, it's just doing a proxy, like there's no bad behavior going on there at all. But I can put requests to that control socket to switch on and off various behaviors. So all right, now switch on your error behavior, and I'll start getting errors. Now switch on your hanging behavior. Yes, remembered what sequence I did these in. And it will, do the same thing, right, until I interrupt it.
I think some New Zealand ISPs are running very
And you can switch off to doing nothing with this dummy behavior like this. So this is really nice for, if you've got a particular failure scenario in mind, this lets you kind of play it out in real life in a more controlled fashion. And that has proven to be, really useful for us. So I actually have on this, dummy Firefox Sync server, I have an instance of Vaurien between it and its database. It's not doing anything at the moment, like it's just got the dummy behavior enabled. But if I tell it to enable its error behavior, same deal as before, I just post to that endpoint. And then I try and talk to my server. We'll see two things happening. The first is that this takes a long time because the Firefox Sync server is trying to retry your request in the face of these errors. And the second thing we'll see when it comes back, is that particular error from your database corresponds to a crash in the Firefox Sync application, which has been captured and logged under this unique ID, and we can go and find in the log. So that's, this is a good behavior of our server in the face of that error. So how might we use this?
Do you have a nice way to catch an exception? Like, is this the same library, or is it?
I can talk to that at the end if you like. So the first thing I'll suggest is turning this on and see what happens. Like turn on 10% error rate from your database and see what the error rate is coming back from your application. If you're really good, it'll be 10%. It probably won't be. The other thing that you can then do if you've identified specific failure cases is put them into a test suite. So this is kind of an example, if it works, from the Vaurien docs, where they have some Python for controlling this behavior. So you have start proxy, stop proxy, and a little context manager to say with this particular behavior, do some tests, disable it, and work it into your test that way, which is pretty sweet. So summing up, things that I kind of want people to take away from this talk is to just think about how your app interacts with the world around it. And that can be really tricky to think about because we're used to depending on everybody else's services doing what they're supposed to do. Like if you were in the talk yesterday, sort of everybody else is a genius and their code works perfectly, which is a very, we can be hopeful of that, but it's nice to be prepared otherwise. What happens when the outside world misbehaves? And does it matter? Like, we kind of have to stand up in the face of some of these failures, but maybe you don't. Maybe you just want to check that your app fails cleanly when your database goes down and comes back cleanly when your database comes back up. Awesome. But you should be able to test for that, and you should be able to simulate those failures under controlled conditions and verify that your app is handling these failures gracefully. And the point I really want to make is if this stuff is interesting to you, and hopefully it is because you came along to the very last session of this conference to hear about it, I'll invite you to come hack with us. Sort of we're working towards this notion of doing continuous stress testing of our stuff in the same way that you might use like Travis or something for continuous integrations. Like we should always be able to load against the deployed version of our system, track how its performance has gone over time, track how its error handling has gone over time, and so forth. So it'll be great to find collaborators and other interested parties to work with on that. A special thank you to my teammates. Some of you might know as some luminaries of the Python community, Tarek in particular is a crazy, awesome, super genius who kind of pushes a lot of this stuff forward. James is my long-suffering QA guy on Firefox Sync who makes sure we're trying to actually break stuff all the time. And links to read the docs. And I'm not sure how we're going for time for questions, but I'll be happy to take any. Other than that, thank you very much for coming out.